Hmm. I'm here testing sound. Oh, excuse me. Sound. Am I centered on the screen? Hold on. Am I? Yes, I think I am. And then I have my thing here, my other thing here. I guess we're ready for this, no? Um, anything? Yeah. Microphone. My phone is my phone on silence because it has happened before that I got a call in the middle of a live stream. Okay. And yes, I'm gonna need this today, which is finally working since last. Alrighty, so yes. Hello. Hi everyone. How are we doing? If you're new to the channel, my name is Jose Luis. This is Parametric Camp. We do live streams, computational design, we record tutorials live, we experiment, we tinker, we break things, then we try to fix them, we learn from that. It's a it's a journey, let's put it that way. uh, all right, a lot of beautiful people. Nicolas, Drilon, Albert, Gustavo. Ah, yes, Gustavo. I've met you before recently. Gustavo Avellaneda Malagón. What a majestic name. Beautiful. All right. Welcome, everyone. So, if you don't know us, you can follow us on social media. We have a Discord server where we keep the conversation alive throughout the week. That's where I get the chance to meet people like Nicolas, like Albert, with whom we've chat. And actually, part of what we're doing today is because Nicolas, who's on the chat right now, actually suggested this week, like, hey, this new thing came up, you may want to take a look at that, and I thought it was actually interesting, so we are going to take a look at that today. If you want to know when we go live, it's mostly every week, not always, but for the most part, typically on Friday mornings, like right now. But if you really want to know, probably the best thing you can do is subscribe to the channel, turn on notifications. You will get a pop-up on your phone whenever we go live. And you can also subscribe to the Google Calendar on the link that is on the description in this video. Okay? And then you will get like an event on your calendar or something like that. Has anyone? So I actually don't know if that works. I do it every week. Can someone in the chat confirm if you are subscribed to the Google Calendar? Can you confirm that the event shows up on your calendar when we go live? Is that a thing? Just please, just let me know if we're doing that. Uh, so what are we doing? What are we doing today? Okay, so we are. It shows up. Thank you, Nishant P. Yes. All right. So what are we doing today? Today we are. We're gonna do two things. So if you remember, we just finished. Finally, yes, we just finished the advanced development in Grasshopper playlist that we have been doing for almost a year. Because I also took like a little bit of a break from streaming last year, personal stuff, etc. But it's done. We recorded everything, and I actually have scheduled all the videos to be published. And the last video will be published next week on Monday, and that will be the end of it. And it's already ready for people to use it to learn how to customize and get better at Grasshopper development, on plugin development, etc., etc. That's too. How are you doing? Very good to see you. And do we have to congratulate Arastu? He's publishing a paper on RemoSharp very soon at Cadria, the Asian. I'm not sure what the initials stand for, but something about computation and architecture and research, etc., etc. RemoSharp is the plugin that Arastu has developed, allows two people in opposite sides of the world to communicate together and to work together on the same Grasshopper definition. We did a demo here in Parametric Camp. We have a video of that demo on the playlist that I was just talking about, Advanced Development in Grasshopper. And he just wrote an academic paper to document his work and the experience and how this could contribute to the general community, which I think it's a really, really nice thing to do. So big thumbs up at us two. And you got to tell me about the experience, because it's this month, right? It's like in 2 weeks in somewhere in North India. Is that correct? Very nice. Also, going back to the playlist, remember, let me show, what are we? Can you believe, folks, I still have not opened the Stream Deck that the three wise men that Santa gave me this year. I still haven't opened it. I'm still doing manual key. But if we do this, if we go to the playlist, I am also very happy to share that if you remember the playlist, so this video, you probably can't see it right now, but it's the video that will be published on Monday. It's the new introduction, and I will delete the old introduction because it's obsolete now. But if you remember, we just published recently this video on the design of Grasshopper plugins. This got published on Monday, and it already has almost 4,000 views. It's kind of crazy. I don't know what to make about this. Maybe people just don't want to see my face too much, and whenever there's other faces, the video is suddenly a bit more popular. I don't know. I'm not sure if that's the reading that I want to make. Anyway, I'm going to choose to make the reading that Andrew, Raja, Andy, and Mike are really, really badass, and of course they draw a lot of attention, and people want to hear about their experience developing Grasshopper plugins. That's the takeaway that I'm going to make. I'm also very happy to report, by the way, that we are at 12,000 followers. Woohoo! Can we do? I wish if I had the Stream Deck, I could probably press some buttons now and get some fireworks or something, which I do not, because I just don't have the time to set it up. But yeah, it's crazy. Remember 2 years ago when we started? Was it 2 years ago? I think it's more like 3 years ago now. But yes, I want to take this opportunity to thank everyone who is interested in the work that we do. It feels very nice to be able to do this in the company of smart people. It feels very nice to be in the company of 17 people right now on the live stream and not do this alone in my room. And I'm also very happy to be able to have the chance to build a small community around people interested in these things. It's always very nice. Which reminds me, again, if you really want to be more an active part of that community, join the Discord server, because the Discord is really the place where we actually do have conversations, we share opinions, things happen. And again, for example, today, part of what we're going to be doing in the live stream is because Nicholas suggested, like, hey, have you seen this? And I thought it would be very interesting. We're actually going to tinker and try it live. I may fail. We may not be able to record a video, but whatever. Okay? Anyway, excuse me. Excuse me, sorry. All right, so less talking and more doing. So what are we doing today? Well, today we are going to... what are we going to do today? So if we go to the playlist... Remember last week we recorded this video, which is still not published, but it will be published next week, I think. Yes. Wait. Yeah, it has one view. Yeah, this was me. Yes. So this video will be published on Monday, and I think on Wednesday, but we recorded it last week. It was a piece on Bitwise operators. And if you remember, Bitwise operators are basically this operation in computer programming that allows you to work independently with each one of the zeros and ones of a particular number. And it turns out that it has a lot of very interesting applications. And also it turns out that it's very, very, very performative. It's like one of the fastest operations that you can do at the computer level. So what I would like to do today is I'm going to record a video specifically doing a few examples of why this is useful, which is something that we didn't quite do on the video. On the video, we basically explained how they work and what kind of operators can you choose from, but we didn't really indulge in the utility, in the real world examples of what they can be useful for. So we're going to be doing that today. And the other video that I would like, I don't know if that's going to turn into a video, but Nicholas suggested the other day on Discord, there was this thing called Grasshopper async components developed by the Speckle team. Speckle is the thing that it's basically a company that is trying to create interops tools or tools to make things talk to each other, different softwares. And it looks like they have developed this template for creating components that work asynchronously, or in other words, that don't block the update chain of Grasshopper if they have a very heavy operation. And then when they finish the heavy operation, then they trigger the update and then the thing complete. Basically, if you've ever had a very heavy Grasshopper definition, and when you change something, it takes a minute to recalculate, this could help you not block Grasshopper while the full minute thing is calculating. It will help you keep it responsive. So we're going to just give it a try. We're going to try to build something with this. If it works out, we'll make a video. If it doesn't, then quong, 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 I guess. Then we're not going to do anything with it. So I think that's a little bit of the agenda for today. How does this sound? You excited? Do you want this? Do you like this? Any other suggestions? All right. Walid, Eric, have I met you before? I'm not sure, but if I haven't, it's a pleasure to meet you. And let's do this. Okay, so I'm going to close this. I'm going to also close this. And we're going to start with bitwise operators. So for that, I'm going to go to the example that we did last time. In the last video, am I recording? I am recording, yes. Learning C#, bitwise operators. Should I make a specific exercise? Yes, we're gonna do an exercise. Okay, so I'm just going to do Visual Studio. Oh, what is this? What have I done? New project, console application for the .NET framework. We're going to go to the parametric camp GitHub, learning C#. We're going to do, what is this going to be called? E08, bitwise operators. And then we're just going to drop it there. Yes. E8 bitwise. Nope. Oh, I'm a little slow today. I think I need to drink more coffee. Have folks here drank their morning coffee? Or maybe not. Maybe this is finding you at the evening, your time. So yeah, probably not a good idea. Okay, so I'm gonna try to do the thing first, and then we're gonna build it together. So I want to do two things. I want to do three things. I want to do, first of all, I want to see if we can figure out using bitwise operators if a number is even or odd. So that's because that is basically looking at the bit in the last position. So what we can do is we can say, let's say that I have something that is called the value, and that is 191. So I'm going to create something that is going to be the flag, and that's going to be, it's going to be 191, and then if we want to just cancel out, so I think what we will need to do is we will need to do and the number 1, and then console write line I'm going to see if that is true, and then I'm going to run this, and then this is the number 1, and I'm going to crank this up a little. The width is going to be 80. I'm not going to let the system position the screen. The layout is going to be 24. No, it's going to be bigger. Properties 36, and the options, the layout, the font, the height is going to be 15. Something like this. Yes, I like this better. Third round of coffee. Okay. Maybe you're pushing it a little too much, Gustavo. Okay, all right, so that looks good. And then if I do once, yeah, sorry, this should be value, right? Yeah. And then if I do this and I do this, it should be 0. Okay. All right. So what I could do is I also Boolean is even, and then I can say flag equals equals 0. And then this is even. And then we can do is value even, then book. And then is 19 even? Yes. Is 91 even? False. Okay, well, this looks good. So that's the one thing. Modulo operator. No, actually not modulo, even odd number. So that's going to be the first example that we're going to do. Then the next example that I would like to do is RGB extraction. RGB extraction from a color. So this is actually something that I use all the time, and I also teach it a lot. This is also perhaps my hidden agenda of why I wanted to make these videos all in the first place, because it's something that is a little tricky to understand perhaps if you have never been exposed to this. So let me see if I can RGBA as int representation, if I can see some kind of image. Nope, 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 no. RGBA as int 32. Yes, there you go, this one. If we take this, Wikipedia's, where is Wikipedia? This one here. Ah, right, yes. RGBA 32, ARGBA 32. I think it's this one, the one that C# uses. I actually don't know. So we're just gonna try it. So basically, I will explain this in the video, but basically when we create a color in most in lower level programming languages, the color with the 4 channels gets stored as one integer, 32 bits integer, and the bits get stored. I think I need to explain this somehow better. But anyway, but then they get stored as correlative numbers, one after the other, in one single 32-bit integer. So using bitwise operators is one of the best ways to extract just the red channel, or just the green channel, or just the blue channel, for example. Ah, Nicholas, huh? You never, this is a very low-level thing. It's just so much faster to do this way than with functions or with any other. Yes, you do need to write shift, exactly. I'm going to show that right now. So for example, let's say I make a color. For example, I make a color. I may need to add system drawing. Yes, I make color, for example, and what is it going to be? I don't know. So color from RGBA, ARGBA, and then you can see that you get an integer. So alpha color red green. Okay, so we're going to do so that we can get the 4. So we're going to do 64, 128, 191, and 255, and an ARGBA. And if I print this to the console now, you're going to see that it's going to give me some really strange integer. Oh, actually it doesn't. Okay. So I wonder if, is there any way to get the integer value? Is named to ARGB and AR equals get brightness, get isn't is known is name to ARGB to know. So I can't get the integer from that? Oh, weird. Let me find that out. Okay. Can I cast it to an integer? No. Can I do as int? Does this work? No, because it's not a nullable type. Cannot convert via a reference conversion, boxing, wrapping, or null type conversion. I really want to make this example seriously. Hey, Andres, how are you doing? Color to ARGB? What does it mean? It gives an integer. The 32 ARGB value of this color. Okay, wait, so if I do 2 ARGB, I get the color. Yes, exactly. So what we could do here is we could say this, or we could say int color int, and then we get color.2ARGB. Okay, which is how it is represented internally, actually. Oh, and then here we could just color int, okay, and then we get the number. All right, and then here's where the nice thing comes. So we're going to mask, so we're going to say the red. I actually don't know if it's the red because I don't know if, I'm assuming we're probably doing ARGB, so that's probably going to be blue. So the blue is going to be color int, and that's going to be, and that's going to be, I guess, 255, correct? And let's see if that works. I'm going to print blue here, and we said blue was ARGB, should be 255. Oh, it works. So now green is going to be color int, and we're going to shift it to the right 8 positions, and we're going to end it with 255, and that should be green, blue, and then this should be green, and we're going to try this, and it's 1, which ARGB, yes. So it looks like it's working. I always forget, and then this is going to be 16, and then this is going to be RGB, and then we will have A here, and which I'm going to 24, and that's going to be A. Okay, RGBA 128 and 64. Okay, and I guess we could do this. So this is by far the most performative and the fastest way to get the RGBA colors from an integer representation. It's also the way to compose your own RGBA colors if you want to do it from scratch without using a struct that lives in your system, etc., etc. All of that. So that's the second one. And the third one that I wanted to do was just basically kind of a way to store flags. So we might sometimes be in a situation where we have a lot of different conditions and we want to respond specifically to all these different conditions, right? So for example, you can say condition 1 is true, and then that's true, the second is false, and the third one is true. Condition 2, condition 3, condition 4. And then what you can do is you can create a mask that has zeros and ones. So for example, can I shift a Boolean value? Int shift equals condition 1. You cannot. That's too bad. Bool and integer. But I guess you can cast this guy, no? No? Can I convert type bool to integer? That's kind of lame. Really? Cast bool to int. Seriously? I mean, that's what I'm trying to avoid because it doesn't look clean to me. It feels like there should be an automatic conversion. Okay, never mind. Conditional, and then this would work. Yes, shift. So that's going to be the mask. And then the mask we can, or in condition 2, 1, 2, and then shifted by 1 position, and then we can do that for the third or the fourth. And then we can print here the mask, which should be 1, 1, 0, 1. What is that? Let me do this. So this should be the number 1? No. Oh, wait, because this is 2, this is 3. Yes. No. This doesn't sound right. Up. What am I doing wrong here? So if I didn't do this, if I do this, I get a 0. Okay, and if this was true, I get a 1. And then if I OR it, I should be getting a 2. Maybe it's the parenthesis, maybe it's the precedence. Because maybe this takes precedence. Maybe it's that. Yes, that was it. Yep. That was it. And okay, well, good to know. Good thing we did this before. Yes, and we got the number 15. And this will make the number 14. Okay, and then we can say switch based on the mask, and then case 1 or case 3, and then do something. Yeah, it's going to be And this is going to be a little case 1, case 2, case 4, and case 8. This is the case where only one of them is true. Only one of them is true. Huh. Yes, and if two of them are true, that could take a lot of shapes. If one of them is true, if two of them... Well, maybe that is not because we could count how many of them are true, just with a number. But you get the point, I think. And I would have to draw a diagram for these two. Okay, I can draw a diagram. It's fine, I think. Because I do have... Wait, is this on? Is my computer alive? Oh, yes. Okay, wait. So let me see if I can connect to... I can connect to my remote screen. Nope. Here. Connect to a wireless display. Yes. There you go. Oh. And then sketchbook. And we got the sketchbook here. And where are the layers? Layer editor. And you can see the layers really. Yeah, here. Okay, so we are good. We're working. Okay. And wait, and my thing works? Yes. Okay, finally. Okay, so I think we're ready for this video. Any suggestions? Any comments, folks? I'm going to remove all of this here. Okay, so for the first one, I'm going to make a diagram here. I'm going to say 0, 0, 1, 1, 0, 1, 0, 0. Actually, let me give a... and 1. So that's going to be one thing. So what I need to do is I need to say and I need to do an and I need to do an AND operation. And then if I do that, this will get cancelled. No, let me do that with red. This will get cancelled. And then whatever we have at the very end will be and like that. How does that sound? Okay. I think we can probably do this. Okay. So, all right. So let me start by writing here int value equals 191. Boolean is even is 191 dot modulo of 2 equals 0. And then is even. Okay, so we can start here, and then what I can do is I can make the alternative, which is figuring out if doing an AND operation with a value of 1. Okay, so I'm going to start with this, and I'm going to explain, and we're going to do the introduction later. So let me put here, record introduction, folks. Okay, I'm going to do this. Where do I put it? Here, record introduction. Okay, let's get started. Okay, let's get started. So the first example that I would like to show you is how to use bitwise operators to do a very common operation that we do very often, which is figuring out if a number is even or if a number is odd. So the way we would do this without bitwise operators is to just have a number, right? And then what we will probably typically do is use the modulo operator to figure out if the remainder of dividing that value with the number 2 is either a 0 or a 1. And if it's a 0, it's an even number. And if it's a 1, it's an odd number. So if I run this code here, you can see that yes, this is false. Or if I am a little more verbose about it, I can just say is value is even, and then it says false, right? Because the modulo of this number and 2 is equal to 1, okay? Well, in bitwise world, we can do a very, very similar operation, because at the end of the day, if we have any number and the number is represented in binary, remember that each one of these numbers represents a power of 2, right? And I actually don't know if this is the value of 191, but what is very easy to see is that if we want to basically figure out if a number is even or odd, the only value that we're actually really interested in is the very, very last digit. And if the very last digit is 0, then the value will be even. And if it's a 1, then the value will be odd. So with bitwise operators, what we can do is we can perform an operation where we clean up every single other bit of the number that we're not interested in, and we just keep the very, very last value. And therefore, we generate a new number that will be 0 or 1, and which we compare to figure out if it's an even or an odd. So what we can do is we can say, well, what about this? What if I were to take this number and do an AND, a bitwise AND operation, where I basically take every one of the bits and I do an AND operation with the decimal value of 1, all right? Which is all zeros and a 1 at the very end. If I do an AND operation bitwise, you can see that no matter whatever the values at the top were, when they get AND with the value of 0, they're always going to cancel out. They're always going to become 0. So 0 and 0 and 0, 0 and 0, 1 and 0 is 0, 1 and 0 is 0. So whenever you AND with the bit 0, it always turns into 0. So we're basically canceling out all the information that we don't need. But then, at the very last bit, if we AND that with the value of 1, then if this is 0, the result will be 0. But if the above is 1, then the result will be 1. So by ANDing, this sounds awful, by AND in the original value with the value of 1, what we basically do is we cancel all the bits that we're not interested in, and we end up with the 1 bit that tells us whether if it's even or odd. In this case, if the result, the remainder is 1, it means that it's odd, and if it's not, it's 0. So the way we can do this is we can just rewrite this in bitwise form and say is even is going to be equal to the value, right? And then ANDing, where is this? ANDing, if we AND this to the value of 1, and then we say, can we take this, and is this equal to 0? And if that is equal to 0, then the value will be even, otherwise it will be odd. So is 191 even? It's not even. Is 190 even? Yes, it is even. Is the value of blah, 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 blah even? Yes, it is even. It doesn't matter. It doesn't have to be only 8 bits. Okay? Beautiful. How was that? Now, please remember as well, we have done this to basically figure out if the number is even or odd, but this very same technique that we're using here also works to figure out if the number is a perfect power of 2, is a perfect power of 4, is a perfect power of, a perfect power of 3, of 4, etc., etc. If we just, instead of using the value of 1, we just use other values here. You know what? Take that away. Take that away. I did not do a good job saying that. Okay? Remove that. We will remove that from the video. Okay. So now I'm going to copy here RGB extraction. And color, get color red. We're going to do this. B, yeah, right. And then we're going to print to the console RGBA. Format, string format, yes. A, B, no, R1, B, G, sorry, oh my God, G, B, 3. I'm going to string format this, and then this is going to be A, R, G, and B. And this. Okay. All right. For this, I also want this here. Yeah. And I will also want some kind of diagram here. Say again. So how are we going to do this? So we're going to say, for example, yeah, we're going to have whatever. 1. I'm going to write a bit more center. 1, 1, 1, 1, 0, 0, 0, 0. Okay, that was a lot already. 1, 1, 1, 1, 0, 0, 0, 0. Then 1, 0, 1, 0, 1, 0, 1, 0. Then RG. Then this is going to be 0, 0, 0, 0, 1, 1, 1, 1. and blue is going to be whatever. 1 0 1 0 0 1 0 1. Okay, so the first thing that I do is we end with 0 0 0 0 0 0 0 0 0 0 0 0, and then we do this. Okay, then we will get 0 0 0 0 0 0 0 0 0 0 0 0 0. I'm just going to lazily here, I'm just going to do zeros, and then I will get 1 0 1 0 0 1 0 1. That's going to be the first one. And now, if I want instead to do, so what I would like to do is I would like to shift by 8 positions. And what that will mean is that I will end up with 0 0 0 0 0 0 0, and then I will end up with 1 1 1 1 0 0 0 0. I will end up with 1 0 1 0 0 1 1, and then I'm going to end up here with 0 0 0 0 1 1 1 1. And if I now and this with the value of 255, which I didn't add in the previous layer, by the way. Where is this? Yes, so here I didn't quite, okay, so where is this? So I guess not this. Where is the eraser? The eraser is here. Oh, that's a terrible eraser, this one. And then I want to, if I end, nope, this one. If I end with the value of 255, then, okay, so now this looks better. So if I, okay, if I do this and then I end this, then it's going to be 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. What did I do before? Wait, what? Wait. Wait, you're seeing it, but I'm not. Wait, this is so strange. Oh, you can see it, but I cannot. Oh boy. You can see it on the stream, but it's... weird. So if I do this, it's actually drawing, but I cannot see it on my end. It's not refreshing on my screen for some reason. Let me disconnect and connect again, because I am not... I mean, is it this terrible? And then I should have another layer. Yes, I just can't work like this. I'm going to disconnect. But you can still see it, which is weird. Because it's in my other screen. Okay. And then maybe I can project to the screen. Okay. Okay, and then we are here, and we are here. So then after that, what we should get is all of these cancel out, and then I do get the values of the green channel. I think this should work to explain the whole, to tell the story. What do you guys think? I think we can tell the story enough, good enough with this. Okay, all right. So let's go back then. Okay, so let's do this. 127, and 63, for example. Okay. The second example that I would like to go over in this video is one that I find myself using very, very often, and perhaps it's my secret agenda for this video to explain this one, which is channel extraction or color extraction from an integer that represents a color. Let me first explain what that means. Depending on which programming environment you're working in, maybe you have some way of defining color as a data type. So maybe, for example, in C#, if we bring in the system drawing library, then you have access to the color struct, which you can use to construct or to create colors, for example, from ARGB. So in this case, I am creating a color that is fully opaque and is RGB 191, 127, 63, which I don't even know what color that is, but it doesn't matter, right? So maybe you can create colors like that, or maybe you are taking or you're reading colors from an image and you're taking them in this format, in the color structure. But then what you're interested in is in actually figuring out the individual value of each one of the channels. So you just want to know, given the color that you have, that you want to know the alpha value, you want to know the red value, the green value, or the blue value, right? Depending on where you are, you may have access, for example, to these properties here, which just give you right away, given a color structure, they give you ARGB, okay? Which is fine, and you can use them to extract, you know? But if you're doing this very systematically and with tons and tons of values, depending on the structure that you're using and how heavy it might be, and what functions are underlying these accessors, it may actually be a little expensive. In C# it's not too bad, but I've worked in other environments where getting the green or the blue or the red of a color using functions is actually very, very slow. And if you're doing this for the full image for every pixel, it just takes a lot of time to do. So one thing that I would like to introduce you is the fact that very, very often in memory, when we want to store a color that has 4 channels, it's a very, very common way of representing this color as an integer. What? Okay, let me show you that. So if I create this color with these properties and then I do this thing where I say, can you, from this color, give me the ARGB value? Turns out that this returns a 32-bit integer value. And if I print that to the console, it turns out that color 255, turns out that it's like minus 4,000,2027, blah, blah, blah. Why is that? Well, it turns out that storing 4 values that can only go from 0 to 255, storing them in one integer that is 32 bits long, turns out to be a very, very efficient way of saving this in memory, because you're basically not wasting a single bit of memory. That means that what that means is that the way this happens is that what we can do is that if we know that each one of the values is just 255, 256 values, what we can do is we can pack the zeros and ones of each one of those channels consecutively in a value that has 32 bits, where we just put the zeros and ones one after the other in this structure. When we put this together, they become this like unintelligible integer that is very difficult to extract meaning from. But what we know is that the zeros and ones that represent the alpha, the red, the green, and the blue, we know where they are, we know in which position they are, etc., etc. It's just that when they're combined together, the integer that they form is something that is very difficult to understand. But it's a very fast and very efficient way of packing this information. So I have found myself very often in the position of having a color that has been stored in memory in a database, transmitted from an API or whatever, store in this kind of 32-bit integer representation. And I needed to find an efficient, fast way of just picking out the red, the green, and the blue. So how are we going to do that? We're going to use bitwise operators because it's by far the fastest and most performative way of doing that. So how does that look like? Well, let's imagine we have the 32 bits of that integer, okay, represented as sorry, let me say this again. Let's imagine we have the 4 colors packed in zeros and ones into a 32-bit integer, right? And what I'm interested in is for example, let's start with the blue color. If I just wanted to get the blue color, then if we follow the example that we did before with the modulo operator, then it's probably quite easy to understand that what we can do is we can just do an AND operation, a bitwise AND operation with the value of 255. And the value of 255 is basically all zeros and then 8 ones, which means that if we AND the integer with all these numbers, everything that is here is going to be cancelled, so that all these digits, when we AND them with the value of 0, are going to become 0, and then all these numbers, when we AND them with the value of 1, they're going to be whatever these values were here. So finding the blue channel is actually quite easy. It's just taking the integer and ANDing that integer with a value of 255. So let me then rewrite that for us. So what I'm going to do is I'm going to cancel all of this, and I'm going to say I have the integer that I have extracted from color. So can I now compute the blue color by saying give me color integer, and then can we AND this value bitwise with the number 255? And let me make sure that this is working. So I'm going to print to the console the value of B, which should be RGB, should be 63. So I'm going to run this, and you can see that, yes, we are getting the value of 63, the 63 on there, okay? Beautiful, so that works. So, but what about the other ones? Sorry, I was seeing in the channel that there's some problem with my audio. Is there a problem or not? Because on my end, it looks good. I have battery here, and I do have battery here. Yes, it looks like I have battery here. Let me know if this is still an issue. Okay, so we were saying, what about the other ones? Well, let's say that we now wanted to just extract the green values, correct? Something that we could say is, well, maybe what we can do is I could AND the integer, the 32-bit integer, with some number that has all number ones here and then all zeros here, and then the rest of the values are zeros all the way here. And then we would end up with the green values over here. But that is probably a good start, but I don't like that approach because we would end up with a number that has the important digits somewhere here after 8 bits, which is not going to give me a clean number from 0 to 255. It's going to give me a number that is going to be in a much higher order, and I would need to end up translating that somehow to 0 and 255. So that doesn't quite work right away. So what we need to do is we need to actually do a small operation before, where what I would like to do is I would like to make sure that the values that I'm interested in, the values of the green channel, are somewhere in the area where if I AND them, they will turn into 0 to 255 values right away without any further transformation. And if you remember from the previous video, we have learned that something that I can do also bitwise is take the numbers, take the zeros and ones, and move them around horizontally in the number. And that is with the bit shift operator. So what I can do is I can say, well, you know what? What if I, oh, this came out in the wrong layer. So forget about this stuff here. So what if I take this integer and I shift all the bits 8 positions to the right hand side? All these zeros will appear at the front, and then the gray values are shifted 8 positions, the red values are shifted 8 positions, the green values are shifted 8 positions, and the blue values disappear. There's no wrapping going on here, okay? And then if I now take this value, and I AND this number with the value of 255, then I will be basically canceling everything at the very front, and the values that I'm interested in will end up here very nicely in the range of 0 to 255. So when it comes to figuring out the green channel, the blue channel, and the alpha, we will just need to go through the extra operation of shifting everything 8 positions, 16 positions, or 24 positions, and then bitwise ending that value with 255. Okay? So, I mean, that's going to be also quite easy to do. So let me show you. So, for example, int green is going to be color int, and what we're going to do, you can see that you can see the IntelliSense is also suggesting that I bit shift this stuff, which is kind of nice. Not by 16, I'm going to bit shift it by 8 positions. I'm going to make sure that I put parentheses to make sure that this goes first, and then I'm going to AND this value by 255. So what is green? Is green 127? Let me check that. Yes, it is 127. So now I'm going to copy and paste this for red, and for red I'm just going to bit shift 16 positions, and I'm going to now print the red value, which is going to be 191 as we had made here, which is also good. And then last but not least, what about the alpha? The alpha needs to be bit shifted 25 positions. So I'm going to go here and do that. Okay. And if I copy and paste what I had before, so now things are going to be a little cleaner. So my RGBA colors have been extracted on a per channel basis using bitwise operations. Again, maybe in this case in C#, maybe it's not entirely necessary because we have this property which I assume is pretty performative, but I've been in situations where I didn't have that possibility, and then doing the integer bitwise approach was much, much better, okay? So, and also it was a really good example, I think, of like all the potential like mix and match of things that you can do with bitwise operators. I like this example a lot. All right, and the last one. is going to be what? Is there a good example here? What is this? It's nice. Oh, it's a shader toy. Oh, nice. This is very nice. Ooh. We're gonna do shader toy at some point, folks. Don't worry. We're just not there yet. I'm not there yet, but we will do. I'm actually teaching a lot of that on my class right now at the university. Yes. So. Okay. So I think we can do this. Okay. All right. Multiple conditions. And okay. Uh, okay. All right. Okay. All right. Let's do this. The last example that I would like to explain is perhaps a little more abstract. So I'm going to ask you to pay a little bit more attention to what I'm going to say right now. But it's an example where bitwise operators are really handy when you have a situation where you have to keep track of multiple conditions at the same time and where you have to respond to a lot of different combinations of those individual conditions one by one. So for example, let's say we have a situation where we have 4 possible conditions, like true or false, right? And for each combination of those 4 different conditions, if the first one is true and all the rest are false, if the second one is true and all the rest are false, if the third one is true, if 2 of them are true and the other 2 are true, it's basically you have 16 different possible combinations of all those different conditions, and you have to react differently, right? You have to make different things based on each one of the 16 possibilities that you can have. This is, for example, something that comes up for, it has actually come up very recently in some work that I'm doing with people here from the community, actually. And it's, for example, implementing a marching squares algorithm. When you have a marching squares algorithm, you want to create in a grid, you want to basically draw lines that define inside or outside based on the relation of the pixels, whether the pixels are on or off. And because you do it with 4 pixels, those 4 pixels, each one of them can be on and off, which leads to having 16 different conditions, right? So if we were to decide what kind of line to draw based on these 16 different conditions, what we would do, we would basically perform some kind of calculation. So this is hard-coded, but we will basically compute for each one of the pixels, whether if it's inside or outside somehow, we would end up with a true or false value. And then if we wanted to respond to the 16 different possibilities, we would have to do something like this, when we would have to say, if condition 1 is true and the other one is false and the other one is false and the other one is false, then maybe that means that we are in this case here. But if it's not, then if that condition is true, that is false, if that is false, if that is false, etc. And you have to do this 16 different times with 16 different permutations of true and false, which, as you can imagine, it's not very clean. It's actually quite tedious to implement. And for 4 permutations, maybe it's doable. But if instead of marching squares, we were in the case of marching cubes, which is basically the same thing, but in 3D, then it's not anymore 16 different possibilities, it's 256 different possibilities. So writing an if else, if else, if else with 256 clauses, it's, I mean, your sanity would be really affected after after doing that, probably, right? So it's not great. So the way this is done typically is that we use what's called masks to figure out whether if in which condition we are. And those masks are typically represented in this particular way. So if I can find now this one here. So for example, what we can do is we can say, for each one of the conditions, in this case, the corners of the marching squares, for example, square, for each one of the conditions, I'm going to define that each one of the conditions corresponds to a 0 or a 1 in a number that is going to have 4 bits. What that means is that 0, 0, 0, 0 will mean that no pixel is inside of the boundary. 1, 1, 1, 1, 1 will mean that all pixels are inside of the boundary. And then anything in between will be depending on the position of this 0 and 1. We will be talking about whether if this pixel or this pixel or this pixel or this pixel is on or off. We basically assign one position of the 4-bit number to one of the pixels, that has to be on and off. What's interesting about this is that with this nomenclature, what we can do now is that these cases will be much easier to trace, because we can refer to them by number. So this is case number 0, because in binary this is 0. This is case number 1, because this is binary 1. This is case number 2, because this is the binary representation of the number 2. This is case number 3, because this is the binary representation of number 3. This is the case number 4. And if we actually go to the other table, we will probably see that, you see 4, that is top right corner. Here, case number 4 is top right corner, all right? So basically, these cases here are the same cases. It's just that we're flipping between the binary representation and the decimal representation. I don't know if that was clear, but basically what that means is that one way to approach this problem is to say, well, instead of doing a massive if else, if else, if else, what I can do is I can turn these 4 conditions that are true or false into a decimal number from 0 to 15 by doing bitwise operations. What does that mean? Let's say, for example, I'm going to cancel all of this, and I'm going to say I'm going to create a mask. This is typically the name, the technical name that we give to this combination of zeros and ones that comes from true and false conditions. And I'm going to start by setting the number at the very, very rightmost of the binary representation. So the first one is going to be, is the condition one, is this equal to true? If that's the case, then the mask is going to start with the value of 1, and then otherwise it's going to start with the value of 0. And if I were to represent this in binary, this will look something like this. 0b is the way to represent in binary, and it would be 0, 0, 0, 0, and then 0, 0, 0, 1, if we use 8 bits. Okay, I'm going to remove this space here. All right, beautiful. Then what I can do is now I can extend that masks with the second condition. And I can say, you know what, whatever mask is, I want you to OR this, so that is bitwise OR, with the next number that I'm going to compute. And the next number that I'm going to compute is going to be the second condition. Is this true? Yes or no? Then give me the value of 0 and 1. And remember, because we want this condition 2 to be in the second spot of the bitwise operation, on the second spot of the binary representation, I need to shift this value by 1 unit to the right. What that will mean is that it will be 1, 2, 3, 4, 5, 6, 7, and 8. Okay? And if I OR that with this one, and if I OR them together, then maybe I get something like da 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 da, and then 1 and 1. If both are 1. If it's not 1, then it will be one of them will be 0 and 1, or 0 and 0, whatever that is, right? And then let's keep doing that. The only thing that we need to do now is the same thing with the third condition. That is the third condition, and we need to shift this by 2 positions, and this will be 1, 0 here. And then condition 4 is going to be true or false, and this is going to be, and because we're checking if this is true, we can be a bit more elegant here and just remove this because we don't need that. We can do the shorthand version of that. Okay, beautiful. Let's figure out what have we written here. So if all of these were true, this should probably be the number 16, correct? Because it would be 1, 1, 1, 1. Sorry, the number 15. So let's try that out. And you can see that, yes, we do get the number 15 here. If I were to take the one at the very front and make it false, then this should probably be the number 7. Is that correct? Yes, because I'm removing that. If this is, for example, false and false, we only have the very first number. Oh my God. If we only have the very first number, then mask should be the value of 1. Is that correct? Let me try that out. Yes. And if I were to do this false, and then false, and then false, and then the first one is true because it's in the 4th position, it should be the value of 8. Correct? Beautiful. So what that means is that, and I'm not going to do this now, but what we can do now is that we can write a much more elegant condition where we can say, let me just use a switch where I'm going to use the mask as the condition, and I'm going to say, if we are in 0, or if we are in 1, or if we are in 4, then do something. Maybe you have 3 conditions that are the same, right? Or if you are in number 2, or if you are in number 3, or if you are in number 15, then do something else, you know? And then this is typically much easier to maintain, to read, to understand, and we're using a switch mask condition here. But if you have a more complicated situation, then maybe the mask is basically the position of an array that has the information for each one of the particular conditions or each one of the particular data entry that you need to perform that operation. It's more like a search table, like a lookup table, more than a conditional statement. Okay, but this is also a very, very common way of working with situations where you have multiple conditions and you have to respond differently depending on the combinations and the permutations of those multiple conditions. Again, for example, this is very common when you do marching squares algorithms or marching cubes algorithms. Okay? Beautiful. I think this was a lot already. I hope this was understandable and digestible. Thank you for watching this video. If you want to learn more, remember this is part of our series Learning C# for designers or for anyone in general. There's not that much that is particular to designers. And if you like this video, please just give it a like or subscribe to the channel or say hi or share it with your friends or whatever. It just helps transmit the message to the world. Thank you very much and see you in the next videos. Bye. Okay, so now let me record the introduction to the video, and then we take a mini break, and then we come back and we do asynchronous components in Grasshopper. I know Nicholas is very excited about that. So let's do this. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in our series Learning C#. In this video is a starting over again. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in our series. Sorry, starting over again. I just heard myself. Like, I do say the exact same thing all the time. I sound like a broken record. We need to design a new punchline, like "Howdy, folks, Parametric Camp here." So, oh, that was horrible. That was horrible. I'm taking it back. Okay, but we need to think of a new, intro phrase or something for the videos. Yeah, maybe we need to do that, Victor. Like, if only I had my Stream Deck set up and I had like buttons with animations and flashy things popping up like Nono does. Nono is really good at that. Hi, by the way, I didn't know you were there. Victor, is this making sense now? The Bitwise stuff? What do you think? All right, let's record the video. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video in our series Learning C#. This video is a continuation of the previous one in which I explained how to work with bitwise operators and what they are. And in this video, I would like to do a bit more of a hands-on on a few examples of how bitwise operators can be useful. So in this video, I'm going to do three practical examples with bitwise operators. The first one is going to be very simple. It's just going to be figuring out how to calculate if a number is even or odd instead of using the modulo operator, using the bitwise operator. In the second example, I would like to show you how from an integer representation of color, how to extract the red, the green, the blue, and the alpha values, which is actually an operation that I happen to do very often in the kind of workflows that I work myself in computational design. And last but not least, I would like to show you also how with bitwise operators we can create these things called masks, which are very, very useful when we have a situation where we have multiple things that can be true or false, and where we have to respond differently to all the possible combinations of those things being true or false. This is particularly a case, for example, when we are designing algorithms such as marching squares and marching cubes. This technique is particularly useful. So without further ado, let's just do it, okay? Bitwise operators hands-on. Let's do it. All right. Oh, that was a lot. Okay. I'm going to save this. It's already saved. I'm going to stop projecting because my computer is going to blow up. And I don't need that for the next. Yes, I'm here. All right. Okay, folks. Can I take a small bio break? Okay. Can you give me a minute and I'll be right back? Don't go anywhere. We're trying asynchronous components. I don't know where we're getting with that today. Hello, hello. Yeah, sorry, my microphone is not working right now. I'm using a different microphone right now, which by the way is pretty nice, but it sounds different, right? So let me see if I can make this one work again. Hold on. Hello. Hi. Okay. Wait, what? I was muted. Okay, that was easy to fix. Okay. Mm-mm-mm. Okie dokie. All right. So, as promised, as promised, we're going to try to make asynchronous components. So I was saying before, if you jumped in late, Nicolas or Nicolas, I don't know how to pronounce that, from the channel, from the server, Discord server, he shared with us recently this project called Grasshopper Async component from Speckle Systems, which I believe is some kind of template for components to create components. Companion blog post. to create components, to create components that what? To create components that do. I can't do so many things at the same. I can't read and talk at the same time. So to make components that perform asynchronous operations, so that if you have like a very heavy computation or something, you can just buffer it. You can buffer it. It happens in the background, and then whenever it gets resolved, that component triggers the update chain, and everything gets updated after the fact. So I want to try this out right now here live. If we manage to put something together, then we will maybe perhaps make a small video out of it or not. So first of all, let's start by reading the manual. Okay. So what I'm not sure about the last part. It makes your life easier. We'll put this report. Looks nice. It does look. It does look quite nice actually. There's also the best part. Grasshopper and Rhino are responsive. There's progress reporting. They're thread safe. 99% of the times, this won't explode in your face. Well, that's nice. Approach. Propose an abstract async component which can carry to a scaffold your own async component. Okay, so this is what I supposed. What basically this is doing is that when you create a new component, instead of using the standard, instead of inheriting from the standard Grasshopper component, you inherit from their own component, their own template. There's more info in the blog post. Prime number calculator, useless spinner, does no meaningful CPU, but just keeps a thread busy with spin weight. Okay. Current limitation, data matching. So see this PR. This PR was merged. So, okay. Can now nicely handle multiple runs and any kind of data matching. Okay. All right. Flash of null data solved. This now only expire the downstream dependents when they are done with their tasks. Okay, other limit. So that means that when you update it, it doesn't give you nulls right away. It just gives you. Am I still streaming? Are you there, folks? Can someone say hi? I feel lonely. It's not spine downstream when they're with their tasks. Okay, which is nice. Other limitations, separation sufficient if you can batch together as many iterations as possible. Ideally, you'd work with trees straight away. Task cancellation is up to the developer. This approach won't be too well suited for components calling code from other libraries that you don't or can't manage. Use it course, yes. Can I enable cancellation of a longer run? Yes, now you can. If your component, in your component, just add a right-click menu action like this. Open additional menu items tools here. Cancel, request cancellation. Debugging. Quite easy. Clone and open it. Once you've built it, add the bin folder to developers. Yes, so this is basically a way. You should see the component popping up under samples ribbon. A simple, yeah. Contribution, community, blah, blah, blah. Okay, it looks pretty straightforward to me. Let's see if there's anything. Hi, Victor. Hi, Nicholas. Sounds like Dimitri Stefanescu is in here. Oh, and he wrote it the day of my birthday. Oh, October 5th. Yeah, that's my birthday. Sorry that I disclosed that. While working on Speckle, we really need you to you don't like a problem. Latency, Speckle, Grasshopper, janky, and things get big. Blah, blah, blah. Workflow, long running operations, async component. Yes, async component, eagerly, progress reporting. Do not override the self instance. Do not override self instance. Define and set a working instance of a type that implements async component worker. Ah, okay. register. How does it work? You need to create a new component and inherit as a base class this one. Here you can do the standard things you would do with two extra concerns. We don't work with the solve instance, and we need to define a worker. Okay, so that's new. Good thing we're reading manual here. In the you need to define a worker class that implements async interface. The implementation should be quite straightforward. Set data, collect data, and do work. The magic happens in the do work function. You can see this function as a replacement of the solver instance one pre-provided by the Grasshopper components. Okay, so you basically have to create a different interface and get the important part to finish the task cancellation with the do work function. It is quite easy to do. You make just pepper run at the beginning or the end of the function. If check for task and if token is cancellation request completed. Report progress. Get a sample implemented data through a Grasshopper structure objects. Action string, report, action done. To look into it, but yes, looks like a nice document. And performs a heavy operation on each object. And you do here the progress report yourself. Report error. Notice how we check for task cancellation pretty much everywhere we can. Okay, given the fact that the responsibility to check for task cancellation is up to the developer, this approach won't be too well suited for components calling code from other libraries, blah, blah, blah. Few other limitations, mostly covered the important parts of how this approach proved to be quite solid. On display expired, and there's some implementation work that we didn't cover here, like how we're displaying updates without calling the on display expired. And most importantly, there's room for improvement, so we're happy to hear your thoughts and PRs. Okay. All right. I still have sound, right? Yeah. Wait, what? Oh, the sound is so faint. Yeah, now. Why did the sound go down? Oh boy. Did I record the video with the bad sound? Ah, that sounds awful. Is that why HC Zoo was saying before that my sound was? It happened at the mic switch. Okay, I hope I didn't record a video like that. Anyway, okay, so let's clone this and give it a try. No? All right, so we're going to clone this. Where are we? Here. So I'm going to open here a terminal. I'm going to git clone this thing. Grasshopper component. So this is now here. Component async, and this is here. So I'm gonna open with Visual Studio 2022. I know, that's how it was intended to be, Nicholas. That's Victor. You think it happened with the mic switch? Component demo, async component. So all right. So the component instance, component cancellation token, ID, abstract, a class that holds the actual compute logic and encapsulates it is an easy async worker instance, component cancellation token, duplicate, do work, so set data and get data. So this is the abstract class that I need to inherit from, right? So that is the worker instance that they're talking about here. And here we have the async component, the code for the async component, which is the abstract class that I need to inherit from, which is basically adding a bunch of stuff for, okay. And then we have an example here of a Grasshopper async demo. Okay, so let's take a look at this. Sample implementation cycles component. So this inherits from async. Sample useless cycle. Let's go to the prime calculator, because of course. This one, okay. So we have the exposure, the bit, whatever, the parameters, append additional items. So this is for requesting calculations. And then here we are defining the calculator worker as, which is inheriting from worker instance, which is here. Okay. And then this is the, we just basically do the prime, we do null, this is do work, and this is get data, which we then assign to a global property of the object, okay, and then the prime, which gets set at the very end, and then we do done, and done is what is done. Done is some kind of function, okay. Ooh, I see what this means. Okay, so let me build this and see if it works. Well, I have not, sorry. So here I'm gonna add the demo here, debug, blah, blah, blah. Oh, wait, so where did the Grasshopper, sorry, where did the Grasshopper paste the, so in the output, this got copied to what? Program files, Rhino command loaded, debug, binary, debug, where was this? Info object, debug net. This is not where the GHA is, properties, resources. Where did this get compiled to? Oh, and they publish it as a NuGet component. That's nice. The worker instance, but I wonder if this just copying this works. Okay. Okay, so I'm going to build this, and it got copied to bin debug Grasshopper, bin debug net48. Okay, here it is. So this, I'm going to add it to Rhino so that we can, to the Rhino developer folders, Grasshopper developer settings. Let me add here the folder, which is going to be all this stuff here. And then I'm going to, the documentation said that I should have an async. Where is that? RDF. I have a lot of stuff here that I don't even know I have. Cam Horster. Async. Samples. Async. Sample the nth prime calculator. Okay, so what does this take? Oh, and I'm not doing... Didn't I have parachute or What was the one? What was the nice one that just has the tiny name here? What was it? Glasses, parachute? I forget which one it was. I thought I had it here. Where did it go? Wait. Bitmap, parachute? No? Is the one I like. Displays components names on the canvas. Victor, which one is the one you use? Isn't it parachute? So why am I not seeing it? Melano plus? Okay, parachute. Ah, yes, yes. No, but I like yours better. I may need to switch at some point. Okay, so which nth prime number? Take care you convert your CPU. So let's do 100. And then, poop, that was fast. Maybe we need more. Maybe we do need 1,000. And that was also done very fast. Nth prime calculator. Okay. Okay, I guess I need... Okay. What is the maximum value here? Okay, and now, all right. Division, okay. And then we divide this by 100, for example. And the idea is that this one should not update. This one should not update until this one is done, correct? This is quite neat. I like this a lot. All right, so this is working. Which means that it's time for us to make something. So what could we do? Could we make, I don't know, what is an operation that takes a long time to do? For example, something that we could do which takes a long time. Let's say we make a 3D grid. Rectangular. No, do it square. And then let's do like a lot. For example, this and this. And then let's move this by, a series, which is going to start at first number in the series, step size, this many numbers. This is going to be unit C, and then this is going to be, nope, and this is going to be the points, which we're going to flatten. Ah, God, okay. Now, so we're actually going to graph them. And now you see, oops, took 2 seconds. Okay, and we got a mess here. Okay, and if we were to calculate the distance of each one of these to a point, like for example, we are calculating a sign distance field. For example, distance, so this will probably take a long time, right? Oh, 1.3, it wasn't that bad. This was probably worse. Okay. So this was actually worse. And here we have 10 million, a million objects. Okay. I like sunglasses. Yeah, I think I've used sunglasses before. I don't like the one, I'd stop using the one where you have to drop a component and then it turns things on and off. That one, no. So, I don't know. let's make a phony component that just is a for loop and then just calculates like the square root of a bunch of numbers or something like that. I don't know. It's more about trying here. Okay, so I'm going to save this somewhere on my desktop. Just I don't even know why. Okay, and then here. So if I wanted to create a new plugin, for example, using this, I would either do Grasshopper async as a NuGet package, which I've seen they have, or I would basically copy paste this into my project, I think. No? So let's try to start from scratch then. So let's say that I go to Visual Studio and I'm going to create a new project, and it's going to be a Grasshopper assembly for Rhino 7. Okay? And I'm going to do, for example, this might be the sample file that we record for the video, right? So how are we going to do that? Or I could add it to the parametric camp. Oh, okay. So let's just add it to the parametric camp plugin. So where do we have that? So in advanced development, the Grasshopper plugin here. Well, before that, let me update the repo with, because I think we've made changes to C#. Yes. Um, okay. All right. Don't worry, folks. Very soon I will teach you what I just did. Git. Okay, so we go here, and now we have the components, etc., etc. So, so what I can do then is, for example, let's say that I do, for example, I'm going to create here a new folder. I'm going to call async comps. And in async comps, what I'm going to do is, where is the project? The project is here. Project is here. Async components. So what I'm going to do is that I'm to copy and paste the abstract class for the asynchronous component and the worker instance, because I need them. So I'm just going to go to the project here, and I'm going to take these two files and I'm going to paste them in async, in the async folder. And then let's see if this works fine. So async, do I get any complaints? Does this work? And this one, can I compile this? So can I build it? Do I get any errors? Nope, we look good. So it looks like just dropping and pasting then works well. If that's the case, so this is Grasshopper async component. I probably want to change, I may want to change this or not. It would probably be consistent, but that's not the point that we're trying to make here. And then here, I'm going to add a new item that is going to be the Grasshopper template. And that's going to be, for example, fat operation. For example, sorry, let me redo this. I'm going to rename this fat operation component, no? Because that's where we were using this. Yes. Yes, fat operation component. All right. And as per the, I'm going to do this right now, as per the, we have to do first one thing. We have to here, this is fine, fat operation, description, and then async component samples, and category is going to be pcamp, right? That's what we call the other components, correct? pcamp and then data. And so this one we're going to call it async. All right. For the input components, same thing. We just do pmanager.add integer. So and that's going to be iterations, and then that's going to be it, I, and then number of iterations, and that's going to be an item. Okay, and then pmanager add integer parameter, and then result. For example, we're just going to do a for loop that does some kind of heavy operation. Result of last operation. For example, we could try that. And then solve instance. Do not override this. So I'm going to remove this. The bitmap is fine. We could actually do, well, we could actually do resources. Oh, no, what are we doing in the other? What is the bitmap in the other ones? Over properties, resources. Okay. So properties, resources, parametric camp. Okay. So we have, and this fat component that not implemented inherited because, and this is the key, this is the important part. We need to replace this with Grasshopper async component. So what that means is that we probably need to bring in Grasshopper async component here, and then here we need Grasshopper async assembly async component. So we need to override this. And with this we should be fine, except that now we need to add the worker. And for the worker, I want to see the, yes. So we have the async component, the AUD, we have the name, base. Yeah, we have the same thing, base. We have to instantiate the base worker. Where is this defined? Prime calculator worker. Okay, we will need to remember this. So here we need to say, I'm going to instantiate base worker needs to be equal to a new instance of something that we're going to create, which we haven't done yet, which is going to be the fat operation worker, which we need to define. And then the parameters, we can add the cancellation, probably, that's not an issue. A base append, tool strip down, so we probably need to add namespaces that we don't have. So Windows form, is that where this is coming from? Yes, Windows forms. Okay. All right. And then what else we can do? And then there is the class where we actually do the stuff. Okay. So we're going to create a class. It's going to be private class fat operation worker, which inherits from base worker, no? Worker instance. Worker instance. Beautiful. And what do we need here? What do we need here? We're going to first create the constructor, which is calling the base class with nothing in it. Then we have to override the work. But here in the documentation, the override for the do work was much more comprehensive here. So here, cancellation token. And it doesn't have the cancellation token. Where's this cancellation token defined here? In the worker instance. So that documentation is not consistent. But if I do this, this probably works, and then I have access to cancellation token because it's a property. It's not a method. It's not an argument of the function anymore. Okay, that's fine too. We don't need this then. Do work. Then what else do we have? Do work. We have the worker instance duplicate. I don't know why we abstract base worker async component. Okay, so we're just gonna drop this here as well. I'm not sure why we need this, but we're going to use it there. And we're going to need to implement get data and set data. I'm going to copy those from get data. And so here, oh no, wait, this is not where it goes. It's here. Set data. For example, in set data, if cancellation token, and then, so this is the end part. This is the very end. This is get data, which I guess then this is also kind of obsolete, but it's not collect data anymore. They renamed it apparently. Does not implement set data, do work, or get data. Yes. So what I'm seeing right now is that the worker instance has been updated with overrides that have a different signature from the documentation that we were seeing. So what I'm seeing here is that do work only takes, for example, the report error and the action done. So this does not need to be here anymore. Oh no, here's a double. Okay, so let me do this manually. Void do work, void override, do work, no. Override my PC, override, void do work. So potential fixes. I don't get it. Void, okay, let's see if we get the signature. Void override do work. Okay, let me remove this here because it might be getting confused. So we do have the do work, which is an action, string, and double. Yeah, I guess the blog post was outdated, but probably I'm assuming the this is probably updated. Contribution guidelines, the forum, companion blog post. There's more info on the blog post about it. Yeah, because I mean, basically this is 3 years old now. So they probably changed this. So, okay. So, void override. Don't we have? Override, void, and then here, we got it. That do work, report progress, action done. Okay, so that's one. Okay, great. Then we're going to override, void, get data also. Then public override, void set data. Okay. And yes. And here I'm going to copy this strategically so that we have good documentation here. Token doesn't exist anymore. Report error doesn't exist anymore. Then call this function to invoke the setData function. All right, the setData function. And because this is actually good documentation. Here, get data. It will be invoked by the parent company. And then here you can safely say data. Important, do not call it when you're ready. Call the provided done action for the do work function. And then the instance, the duplication instance, get data instance, the work, the class properties, the constructor, and then a lot of cancellation checking. Duplication, get data, and set data. Okay. So let's start piece by piece. So we're going to now get data, which is going to be basically the number of iterations. So it count is going to be -1, and then get data is, I'm going to say int iterations is going to start at 0 if da dot get data at 0 ref it. If this is not true, then return. No, this is how we would do it in Grasshopper. How are they doing it here? They're just taking it, they're not doing any return anything. Okay, that's fine. Just get it. I'm going to rename this so that it feels more like a interim variable. All right, and then I'm just going to set that iterations. What do I call this? Iteration count. It count is going to be equal to this. And I'm going to rename this iteration count. So because we are writing now a worker that is different and then writing things in their standard Grasshopper component input, and because the work, this instance is going to happen somewhere else, that's why I need to fetch my data and then I need to save it in a class property. That's why I cannot use it right away. So I get the data. So this data is available now here. And then in do work, what I want to do is the heavy operation. So how are they doing that here? So we're going to check for cancellation. If cancellation is requested, then just do that. And then thanks, Stack Overflow. While count, we're going to do every for loop. Here we're going to basically, okay, so let me just do something here. So I'm going to say int result equals -1, okay? And then what I'm going to do is for int I equals 0, I is less than iteration count, and I plus plus. What we're going to do is we're going to check cancellation, all right? And if we're not, then we're going to say double square is going to be math.square root of I. Can I make this any heavier? Can I nest a couple of these? Maybe I can do an input here. Where is this? Int nest. It's fine. I just want to do it manually right now. Okay, I just want to, and then I'm just going to nest this 4 times. For example, this is not good practice, but whatever. And then I'm just going to say that the result is going to be this. Okay. And then after, so we're doing a cancellation, we're doing more cancellation, report progress, and we do want to report the progress every iteration to say where we are. And that we're going to do here. Report progress is going to be, what do we need in report progress? Report progress is what? It's a function that takes a string and returns a double. No, it actually doesn't return anything. It's an abstract. Okay, and ID, what is ID? ID is the ID of the worker, which is already a property of the original worker instance, so we don't need to. And this, then the result is going to be whatever. The result is going to be how far away we are. So that should be it. That should be I divided by iteration count. Sorry, that should be double iteration count and this multiplied by 100. No? Report, where were we here? Report, how many times that the nth prime? I don't know if this needs to be a from 0 to 1 or I just leave it like that. Report progress. If prime is equal, okay. And then when we're done, we just call the done function. Okay, so we're done. The result is what it is. But we need to save the result somewhere. So I think we would actually need to do result is -1, final result, and we will need to do here, final result is going to be equal to that result that we just calculated. For example, we could use result as its own thing. Okay, so that we have that, the prime, calculator, get data, and now we have to set the data. And if this is, so we do another check on cancellation, and if we don't, then we just say final result is what we want to output to the component. Is that it? That was it? I'm suspicious about this. Append additional menu items, operation workers. Okay. Get data. Okay, so let's try it then. So I'm going to run this. Is the pcamp. And now it's opening the sample files on my desktop, I think. Is that what it's doing? Okay, pcam components. All right, and these are the vector components. So I guess we would have to make here a async components, for example. So let's see. So where is pcamp? And we have async fat operation. Okay, so this is looking good. And we can cancel. All right, so let's add here like a very fat number. Like 1e to the power of 10. Is that a number? Data conversion from text to integer. Okay, so can we... Oops, no. I mean, it's not breaking. I don't know how to write exponential numbers anymore. All right. Okay. Okay. And then, okay, so e plus 10. 1.0 e plus 10. Nope. So I can't write scientific notation. Okay, whatever. So I guess we just use the number. Okay, ooh, it's working, folks. And can I cancel? Pop, cancel. Oh, this is nice. So do I change here? And then it just gets triggered again. And then it's calculating. Oh, is that number 3? Really? That's the result? Of, huh. The square root of the square root of the square root is the number 2? That doesn't sound right. I mean, that does not sound correct. Are we running into... Okay, the triple square root of 1 million is the number 2? I don't think that's how it works. Okay, so let's do 256. Yeah, that does not work. That is not working well. I don't know. But it is a fat operation. And it's working. Up. No. So can we restart this? Recompute. Huh? So now it's not working anymore? I don't understand. Fat operation. Number 2, but before it was taking just so long. Ah, because it, I think I decreased the number. Okay. Yeah, well, it's working. It's asynchronous. It did not take 6 milliseconds though. Nope. So that's something that they need to, yeah, because it's probably because it's bypassing Grasshopper's measure performance. It didn't, yeah. So, okay, all right. But it does kind of work. So, okay, folks, suggestion. How can we turn this into a video? How can we turn this into a video? What would a video look like? So what we can do in the video is we can introduce, for example, what can we do? We can introduce the concept. So sometimes Grasshopper is very fat and requires a lot of computation. So we can do asynchronous. There's this project called Speckle. They let you make native components that are asynchronous. This will be obsolete probably soon because I believe Grasshopper 2 can do this out of the box. I believe, I'm not sure. And so let's take a look at how this looks like. We clone the repo, we see that it has 2 examples, we explain them, and then we see, okay, how can we bring this to parametric camp? And then we basically do what I just did. We just take, I could be going back and forth with the documentation, but it probably won't be too good. And I also don't like this operation as a heavy operation to do. Okay, any thoughts on a heavy operation that we could implement as an example? That is not this, because I really don't like this. Can we do, for example, I times I? This is lame. This is very lame. A Boolean? What kind of a Boolean? Of a Boolean intersection? I guess, yes. But I would rather just have a simple numerical operation of some kind. I mean, this is very lame right now, but this should at least give the exact same value. Which it doesn't. Oh my God, what is going on here? Why is this not? This is not right. Wow, this is very wrong. I mean, we have to fix this. We can't do this like this, right? Well, is this, what is going on here? This is very strange. So, you're dividing it with itself, right? Oh. Drillin. Okay, can you give me a huge duh? Yes, of course. I'm dividing it by itself, so it's always a value of 1. That makes no sense. That makes total sense. I mean, yes. And this is yes. Okay. Ah, boy, that was very dumb. Thank you, Drillin. So I'm going to then remove this stupid stuff, and then I'm going to now yeah. Yeah. This is what happens when you live stream for 2.5 hours. Your brain melts a little bit. Okay. Yeah, we get the same result. Okay. And we can call this fat for loop or something. Okay. Okay, so I'm going to copy here on my side. I'm going to copy this so that I can, okay, and then we're going to remove everything from the example. Oh, no, I need to remove this from the file. Hi, Anish. Anish Jose? Are you called Anish Jose? Should I call myself Jose Anish? No? Okay. All right, let's make the video. Let's do this. I'm going to remove this from the sample file. Okay. Very good. So now we don't have this. And then from async components, I'm just going to remove and this is, yes. Okay, and from the Grasshopper plugin, I'm going to remove the async components. From there, very good. Towards a less. Okay. So I'm going to explain what we're doing. So we're going to record the intro will be at the end. So the first thing that I'm going to do is I'm going to and then Grasshopper async is going to be here. Grasshopper async. So I have it here, and then I can just open it with this. Open with Visual Studio, and then I show the project. I show how you can add in your Rhino. I show how you can add in your Rhino. You can add to the folders, Grasshopper folders, Grasshopper developer settings, and I added here async component, this folder, so that when I open Grasshopper, I can go to to this sample here, and I can just do the nth prime calculator, for example, and then you can see that I can now drop this, and I still, this is calculating, which is kind of a nice example. I do the, yes, you see? And I can also cancel this because it's too far. Okay, so this one is probably faster. This one is faster. Whoa, okay. This one is faster. And my CPU is not doing terrible. So I do that. I show this working. I show this working. And then I talk about the documentation. So how can we do this? I talk about documentation. How can we do this? I also talk about the post, but be careful. The post is a little outdated. So some of the things that you will find is that these names and this are not working anymore. They're not like that, at least. Okay. And and then I basically just try to do this on my own in the pcamp plugin. Okay. So I think that's what we're going to do. So let's get started then. Okay. So let's get started. Let's get started. Okay, we are getting started. After the intro, Grasshopper async component, I will need to remember to put a link on this on the video. Okay. So let's get started. So how are we going to do this? Well, Grasshopper 1.0 does not let you do this out of the box. But there are ways to do this by basically hacking a little bit the way native Grasshoppers are done. And this is what the people at Speckle Systems have done. What they have done is that they have created a project that is called the Grasshopper async component, in which they're basically wrapping in a way the standard code that we use for developing native components, and they're wrapping it inside of a larger set of code that allows us to use that same code or a very similar code, if you will, but wrap it inside of additional code that makes it work in a way that doesn't block the natural flow of data or the runtime of Grasshopper. So this is what you can see here in the example, and they have a GitHub repo with both the wrapper code for the components and example files. They also point to this companion blog post that explains how do you have to develop such components and what things do you need to keep in mind when doing this. I have found this blog post very helpful, with the only exception that this blog post was written in 2020 and I am recording this video in 2023, which means that I actually found that this example here with these names and collect data and the signature of these functions are not valid anymore for the more updated versions that they have recently published. So don't worry too much about that, because I'm going to explain to you in this video how do you need to implement this as of March 2023. But if you're watching this in the distant future, then some small things may have changed by the time you implement this. Or if you're watching this in the far distant future, I believe Grasshopper 2, whenever it releases, will incorporate this function out of the box. So maybe doing async components using the Speckle template might be obsolete at this point in the future. Okay, if that's the case, you might find examples of how to do asynchronous or non-thread blocking components here in the playlist in our channel. Okay, so the first thing that we're going to do is we're going to clone the code. So you're going to go to the Speckles repo. There will be a link in the description of this video. There might be a card popping up in the corner with where you can find this, and clone this however you feel. You can just download the zip and extract it on your desktop. You can use Git to clone the repo. I'm in the process of recording a Git playlist right now. There might be a card somewhere, or just probably look through the channel. There might be a Git playlist somewhere here, okay? And I've already done that before. I have extracted that, and what I have is a Visual Studio project that contains the wrapper code and a demo of how to do that. This project looks something like this. So if I open it in Visual Studio, what you can see is that I have two distinct projects. One of them is the wrapper code. So this is going to be the Grasshopper async component. Is going to be the extension of the Grasshopper component class that we typically use to create components. What this means is that when we want to create an async component, instead of inheriting, I don't know how to say that, from Grasshopper component interface or class, we will inherit from the Grasshopper async component. And I will explain how to do that, right? And it also has the template code for this other abstract class called the worker instance, which is this instance that gets threaded and that is doing the heavy duty computation and that is reporting progress to the main one that is displaying that progress on the Grasshopper component. Okay, I will also explain how that works. Now, after that, something that you can do is you can go to the actual Grasshopper async component demo. This is basically a tiny plugin that has two components, a useless cycles, I actually haven't tried this one, or the prime calculator, which basically they do have a full implementation of everything that you need to do in order to implement this async logic. Okay, you can look through it. I'm not going to do it in the video because I'm actually going to show you how to do it. But one thing that you can do just to try and see if things work out is you can build this plugin. You can build the async component demo as a solution. You can see that that got built on my system into obj debug component blah 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 whatever. So basically this folder Grasshopper component demo bin debug 48 whatever. So now I have the GHA file which I have added to my Grasshopper developer settings. So now I have the folder here with the Grasshopper async component, which means that Rhino and Grasshopper are now aware of that plugin. And if I now go to the async samples tab, you can see that I have here the sample async component. So if I now, for example, put a slider with a very, very, very large number, you know, and no, sorry, I want a slider. So if I do a slider with a very large number, you can see that the thing starts calculating, and you can see that while it's calculating, my Grasshopper is responsive. I can do other things, I can drop a slider, you know, and the thing is still computing. I can even right click and cancel the operation, like, oh, that's going to take too long, and then just reduce the number, and then hopefully this is going to be much faster now. Faster, yes. And hopefully this is going to be, oh, not much faster. Well, but it's doing its thing. Let me crank this down a little. There you go. 60,000. I don't know. Well, it's taking a lot, but you can see that it's doing what it's supposed to do. All right. So this is probably the first thing that you want to do to try out that things work and that you have a working example from the repo. And then after that, what you can do now is you can bring in that code to have some of the components in your plugin use this asynchronous logic. I can't believe this still hasn't finished. I'm going to, yeah, so let me just substitute this. I think it's just blocked on some previous calculation. I can't believe it's just taking that long. So let me actually, yes, I think it's somehow, oh, I don't know why it's taking so long. Anyway, this was much faster when I tried before in my computer for some reason. Anyway, so, and the next thing that you want to do is take this code and use it to make some of your components in your plugin asynchronous. Let me show you how I would do that with the plugin that we have been developing, the parametric chem plugin. Okay. How are we doing, folks? Okay. Nicholas, are you liking this or what? Okay. If you remember from our previous videos in this playlist, we have this Grasshopper plugin that we call the PCAM plugin, where we're basically just testing a bunch of stuff. So what I would like to do now is just as I have folders for every type of category for every category of component, what I'm going to do is that I'm going to right click and add a new folder that I'm going to call async components. All right. Then in here, what I would like to do is, first of all, what I'm going to do is I'm going to bring the code that I need in order to make components asynchronous. But for that, I'm going to go back to the original repo, the repo that said the async component. I'm going to go to the folder that has the worker instance C# file and the Grasshopper async component C# file. I'm going to take those two files, I'm going to copy them, and back in my plugin folder, I'm going to go to asynchronous components and I'm going to paste those two files there in the folder that I just created. Those files are hopefully going to show up here, and now you can see that I have both the async component and the worker available in my project. The only thing that I need to remember is that because I just copy pasted them, they have this namespace called Grasshopper async component, which I can either replace or rename, or I can reuse for my own advantage. Okay, or I can just reuse as it is. The next thing that I would like to do is I'm just going to create a Grasshopper component that is going to perform some kind of very fat and heavy operation. In my case, I'm going to keep it super simple. I'm just going to make a for loop that it's just very, very long, but it does basically nothing. But for loops, if you do millions of iterations, they actually take quite some time to execute. So I'm going to add here a new item, and I'm going to do as I typically do, an empty Grasshopper component for right now, and I'm going to call this for loop. All right, async for loop, and then let me rename this to be consistent with the rest of the I always have component here. I'm going to call this async for loop, async for loop. Async for loop is going to go under pcamp, and the subcategory is going to be asynchronous. All right. Now, the first thing that I need to do is remember how all components inherit from Grasshopper component. Now I do need to change that because I want to inherit from this new wrapper that has all the nice and asynchronous goodies. So what I'm going to do is I'm going to replace this with Grasshopper async component, which is not going to be available because I need to bring in the namespace that this class belongs to. So I'm going to use using and then Grasshopper async component. And when I do that, now all the stuff in this namespace becomes available for me here. All right. So that's the first thing. Then I'm going to walk you through, you can read in the documentation or you can just follow my case. So register inputs and outputs is going to be the same. So I'm still going to use, for example, I'm going to add an integer that is going to be I, and it's going to be iterations, no description, because I'm trying to do this very fast, and item access. All right. And then P manager is going to be add integer parameter, or for example, add string, add text parameter, and that's going to be message, or m, and that's going to be message, and that's going to be no description, and also an it item. Really, what I just want to do this component to do is to just iterate over a very long for loop and then just say, I did this many loop iterations. Okay. Now here's where things change a little. Remember that solve instance was this function that we used to retrieve the data from the inputs, do whatever operations we have to do, and then put that back in the outputs. Because if that we now need to eliminate, because we basically only have, because if we did that in one single function, that would be a synchronous thread blocking operation. So what this wrapper, the async component, does is that it gives us a slightly different way to perform those operations in a way that is thread friendly, that it allows us to do it in a separate processor and then deal with the results after the fact. Okay, I'm going to add you can still do your icons, so resources. I'm just going to put the parametric camp icon, and the GUID stays the same. Okay, so you still need a unique identifier. All right. Now, one thing that we can add is that we can add the capacity to cancel the operation if it's taking too long. The way we do that is by doing a public override of the function, one of the functions that the asynchronous component is giving us. That is going to be the append additional menu items, right? Tool strip down to menu, blah, blah, blah. So we do the baseline. And then what we do is to the menu, we want to append an item, and that item is going to be the menu. I want to append the cancel operation, and then I need to specify an event handler. So some function that will run based on some function that will run when I click cancel. I'm going to declare an anonymous function that is going to take two methods. So it's going to take two arguments. And here, what I'm just going to say is that I want to request a cancellation. So whenever someone clicks cancel, I'm going to request a cancellation, which is a function that is part of the asynchronous component. So you can see that if I go press F2, I go to the Grasshopper async component original code. So it's part of that wrapper code that is given to us. All right. Beautiful. And for the most part, when it comes to the standard component, the standard part of the component, this is what we need. Okay. Now, as I said, because we don't have the solve instance function anymore, what we need to do is we need to figure out a way to both read the inputs, perform the calculation, and generate the outputs in a way that is not happening on the same thread that regular Grasshopper components do, but in a parallel thread. What the async component framework allows us to do is to use this other template that they call the worker instance. A worker is typically a name that is used in asynchronous programming for all these different processes that you launch in parallel that are happening and then that you manage somehow centrally. You take the inputs and the results from some kind of centralized units. It's a very common term for thread operations or for parallel operations. And what they're basically giving us is a class that we can override with our own parameters to make sure that we do the operations that need to be done for managing those inputs, those outputs, and the actual code. So what I'm going to do then is I'm going to go here and I'm going to create inside of my components so that everything stays a bit more encapsulated. I'm going to create a private class that I'm going to call, for example, for loop worker. All right. And this is going to inherit from the worker instance that is part of the Speckle async component framework. All right. By doing that, what I'm basically doing is I'm taking advantage of all the code that is already here and all the structure that the worker asks me to implement. What does that look like? You can see that I already have an error because this is telling me you need to implement a get data function, you need to implement a set data function, you need to implement a duplicate, you need to implement a do work, you need to implement all this stuff that you have not implemented to have the worker work well. All right, so then let's do one at a time. So first of all, I'm going to declare a construction, so that a constructor for loop worker is going to be equal to just calling the base function with the base constructor with nothing on it. All right, this is just basically a way of initializing the worker. Okay, and then I got one of the requirements done. The next one is going to be what am I going to do? I'm going to do the do work, right? The do work is actually the most important one, which is the one that actually has the whatever algorithm you are trying to do. So for example, public override, and then you can see that it already gives me the suggestion, do work, okay? And you know what? I'm actually going to add them all. So public override, then what else do I need to do? I need to have the get data function. I need to have the set data function, and I need to have the duplicate function, a way of copying itself. So the duplicate function, all right. And you can see that by default, none of them have any code. They just throw exceptions if I run them. So let's start one by one. So let's start with get data. In get data, what we're going to do is we're going to handle the information. We're going to handle picking the information from the component. If you remember, that is akin to what we would do in solve instance, where we would say, can you please give me the stuff that is coming in? We do that from the interface data access. So here we do have the same interface. So it's the same thing. So what I'm going to do is I'm going to define number of iterations -1, and I'm going to say da dot please get the data from the first input in the component, and can you please put it on this variable that I have defined called _it. All right. The only problem that we have right now is that if you remember when we used to do solve instance, because we fetch the data in the same function that we use the data and then we output it, then we were basically good writing all that code inside of the solve instance function. Now we have different functions. We have get data, set data, and do work. So how can we exchange information between the three parts of the three functions? I'm actually going to rewrite this here so that it's a little clearer. The way to do that is by now taking this data and basically storing it as a property of this class. So for example, I'm going to declare a property here that I'm going to call number of iterations, and I'm going to initialize it to -1, all right? When this function gets executed, it reads the amount of iterations and then it saves that in number of iterations. That is so that this value, that is for this value now to become accessible to anyone else in this class, all right? Beautiful. The next thing we want to do is we're going to do some work, which is we're going to perform whatever the calculations. Now, here, what are the calculations that we're going to do? Well, first of all, because we did implement the possibility to cancel, one thing that the speckled people recommend is that because this is asynchronous, the more you check in your code for whether if the user has canceled, the more the code will be responsive to it. So for example, here what we can do is we can check if the cancellation token, which is a property of the base worker instance, if this cancellation token has been requested for cancellation, then we can just stop the function at all right? Then the next thing that we can probably do is I'm just going to say, I'm going to calculate the result of this, which is going to be -1, and then I'm going to do a for loop when I'm going to say for loop int I equals 0, I is minus equals to the number of iterations, right, I plus plus, and then what we're going to do is we're just going to say the result is going to be that number. I really don't want to do or the square root of that number or the cube of the square root of the number, whatever you want to do. But I just want to do like a really long for loop for the sake of making the CPU run a lot. Now, the user may request at some point to stop the thread while the for loop is running, right? So something that we could do is we could say, if this is true, if the cancellation token is like this, then just return, just stop the for loop and do nothing else, all right? And another thing that we can do is while the for loop is running, we can update in the component, we can update how far away we are in the calculation process. So something that we can do is we can use the report progress function, which is a function that comes also with the worker, right? So if it comes from, it actually comes here with, and then what we can do is we can say, this is the ID of the worker that I am. So this is so that the thread safe architecture of this framework is able to place the update of the number in the right component. And then you need to tell me how far away in a scale from 0 to 1 you are from finishing this. So in our case, this is going to be I divided by the number of iterations, and one of them has to be a double so that we don't do integer operation, right? And that's it. So, and then once we're done, the way we need to do is we need to take whatever result we have and make sure that it's accessible to set data. So we're going to use the same technique. I'm going to define an integer here, final result is going to be -1 or whatever. And then here, once we have finished going through the whole for loop, what I'm going to do is I'm going to say final result is going to be equal to that value that we've calculated. Okay? And we're done. Now, what the final result, I did an integer, no, it has to be a double, sorry. Now, one thing that the developers, the speckled people tell us is that we need to remember, once we are done with all the calculations, we need to report from the worker and we need to signal that we are done with calculations. There is a function called done that is passed here to the do work function that we can just call to say, hey, you know what? We're done with this. Can you please output stuff through the output component, right? And then the async component framework will take care of and now executing set data. Set data is going to be taking the data that we're interested in and setting it through the output. In this case, it will be for us final result, which was this instance variable that we created to store the result of the value. Okay. And then here in duplicate, which we need to implement, we just can return like a new instance of the, what is it called? The for loop worker. Yes, like a new empty instance of for loop worker. All right. Okay, are we ready for this? We are not, because one thing that we need to remember as well is that here, whenever we have the async component will always have a worker inside that is who does the work. And we need to initialize that. So there is a property in the async component. Can you see this? It's part of is part of the async component here. Base worker is going to be an instance of that new class for loop worker that we just created. Okay. Beautiful. So because I have linked my pcamp with my Rhino, etc., what's going to happen is that as I press build, this is going to get built, and my Rhino is going to open a Grasshopper file where I already have my pcamp plugin loaded. If you don't know how to do that, I have videos in this playlist where I talk about how to streamlining your development processes and connecting Visual Studio with Rhino, etc., etc. There should be a video, a card popping up in the corner at some point. So just keep an eye on that. All right. And now I have this file, which is the file that had all the components, right? What I had placed here, this bucket for async components. So if I go to parametric camp, you can see that I have a new tab called async, and this is called the async for. All right. So I'm going to place it in here. I'm going to open up a little bit here, and then ta-da! What? And then I can press it here, and then it's running, it's running. Come on, come on. And yes! All right. And then if I change this value, hopefully it will now calculate like something that is, yeah. So it basically just gives me the number that we have input here. So it's not anything fancy, but because it's a for loop that iterates over 55 million times, it kind of takes a while. All right. So of course you could use this to generate, I don't know, if you have like a lot of Boolean operations that take a while, or if you have some code that is just doing a lot of operations, but you want to be able to be responsive or to print data while this is happening, this could be a good way for you. It's actually a really nice project. I want to give a shout out from here to the speckled people. This was a very nice thing to try out. And I could see a lot of components and a lot of development making use of this framework. Thank you very much, folks. And also a friendly reminder, I haven't really looked at the license, but if you use this on your projects, make sure that you are compliant with the license so that you don't, you share that this is part of Grasshopper async, speckle systems, etc., etc. So I'm actually going to do that right now myself, and I'm just going to write here, adapted from these people here. Okay, beautiful. All right, so with this, I think this is what I wanted to do. So I think we're good here. Yes, so thank you very much. I thought this was really cool, actually. I hope this was useful for you. If you're watching this in the future, make sure to check if the things are still written the same way and the functions have the same name, etc., etc. And if you're watching this from Grasshopper 2 world, then maybe there's a way to do this natively in Grasshopper at this point in the future. Okay, but in the meantime, have fun with this. Thank you very much, and see you on some other videos here at Parametric Camp. And maybe like this one, maybe subscribe to the channel. I don't know, whatever you like. Okay, thank you very much, and see you in the next video. Bye bye. All right. Seems I really want to dig into the code. What do you call DA an interface? Isn't just an object? Well, DA is an object, but it's of a type interface. Actually, that may not be true. It may be abstract. I don't know, but it's definitely coming from an interface. An object with an interface type, I guess, but that would still be an object. I have seen others use interface directly as objects. That's what confused me. I think I'm missing. Yeah, we haven't really talked about that in the channel. We haven't really talked about sophisticated inheritance or overriding, etc., etc. We should do that at some point. I'm also going to copy some of that here, and worker instance also from here. Okay, let's make sure that everyone gets proper attribution. That's a nice thing to do. All right. And now I'm going to record the introduction. Hello, this is Jose Luis here at Parametric Camp, and welcome to this bonus video in the Advanced Development in Grasshopper playlist. So in this one, what I wanted to try is this new thing that was presented to me very recently, which is Grasshopper async components, a project that was developed by the Speckle Systems folks, and which is a project that allows you, it's basically a template that allows you to develop native components that behave asynchronously. So for example, if you have a very, very fat component that does a very heavy operation, you can develop it in a way that doesn't block Grasshopper, that doesn't block Rhino, and that while it's doing its computation, you can still work around, you can do things, etc., etc. So for example, I implemented this one called asynchronous for loop, which is basically a for loop that runs however many iterations you want. It does nothing, it just runs a very long for loop. But if you do enough, like for example, this is 100 million times, it will actually take a while. So you can see that the component is calculating, but it's not blocking, it's not outputting anything, and whenever it's done, it just outputs the amount of iterations it has gone through. And I can now change this, and you can see that I can move around, I could do things, and the result will not update until it finishes with the calculations, which is a very, very nice feature. So in this video, I would like to show you how you have to change slightly the way you create your native Grasshopper components so that they can work asynchronously. If you have any part of your plugin that has very, very heavy operations, this is definitely a nice feature to have so that you make the experience for people to use Grasshopper much more fluid and nice. All right, let's talking and more async component development. Oh boy, that was a lot. Boy, I feel so tired, folks. How's everyone doing? Was this cool? Oh boy. Oh, and I have a lot of office hours with students today. Okay, can I lay back a little bit? Sandy, hi, thank you. All right. So I think with this, we're done for today. That we're definitely done. I've been talking for 3 hours now. What are we going to do now? I'm going to go have lunch. Then I'm going to go take care of my students who we have a lot of office hours today. And then I guess I'll see you next week. I don't know what we're doing next week. What are the options? We start with the Brain plugin for ML in Grasshopper. We do an algorithmic modeling challenge just to have some fun. We start thinking about the Git playlist. Ali Brew, thank you. I don't know. Let me know on Discord. What do you think we should do next week? I'm a little empty of ideas, so I'm very open to. I don't know that I want to start right away with the Git playlist. I feel like I want to keep a few weeks where I'm like mix matching topics and just doing like things like we did today. Just let's try this out, see if it works, and we make a video out of it, you know? I kind of want to do that a little bit more before going back to committing to a full months long project like the Git playlist could be. So yeah, just let me, if you have ideas for an algorithmic modeling, like some nice building that we could model, right? Implicit modeling, we're not going to do that anytime soon, Jay. I have a lot of other things that I want to cover. People voted in the so I think that might be a 2024 kind of thing. All right. Okay. Well, with that, thank you very much, folks. It was a pleasure. And I will see you. There are some more repos I found for customizing but buttons and sliders. Could you do an algorithmic approach to landscape? Ooh, we could do something like that. I can send you some ideas on Discord. Yes. So let's do. We have a channel on Discord called Topic Suggestions. Let's move the conversation over there, and then we can decide what we do for next stream. Okay. Thank you very much, and have a good weekend, everyone. Bye bye.